So I will be speaking a little more about, go a little down in from the presentation of Emmanuel Special to more concrete technology, speaking about how to connect data consumers to data sources using some part of the technology we have developed in OntoTrans, the OT API and OT lib. How do we really represent a practical user case? I can speak in general. Anyway, so data documentation, it can be done at several levels. We can start by cataloging the data. That means that describing where you find the data is a kind of essential thing you need to do in order to document your data source. Then you can describe how your data is structured. Define structurally. So we call it structural data documentation. In OntoTrans, we are using formalized data models to describe the structure of the data. Then we have the contextual data documentation. How is your data set related to each other? This really lives in the knowledge base and is little outside what I will be focusing on now. And then we have the semantic data documentation, where we semantically describe our data by related to ontological concepts. So we have different levels of data documentation, and that is kind of what I will focus on now, and also how to utilize this data documentation to really access the data. This different level of data documentation addresses different part of the fairness. So we have cataloging, especially findability, if you have some keywords for, and even more the accessibility. The structural documentation is more this numerical level of interoperability. We have the contextual documentation, really is important for usability. And then the semantic documentation enhance, I would say, everything. When it comes to findability, we saw Fadia showing how it enable exploration. We have, of course, interoperability, where we now get for more from human level to society level to society, and reusability again by providing more relating to agreed concepts in the ontology. So let's then we have this exploration. We saw a great presentation about that. There will be, when you use, Francesca will show how to create and use such a data documentation within workflows. And in this presentation, I will concentrate more on the data documentation, how to use that to get the data in the form you want. This OTE API framework that really tries to address this data documentation. So we have the access, how to access is a cataloging part. It's really, you have. I don't think I will point. It was pointed, so it's sprint. So how you can access the data? We have these data models that describe again the structural concepts. We have the knowledge base, but contextual that lives in the knowledge base is not something we use here. And then we have the semantic documentation that with OTAPI is represented as mappings from properties in the data model to ontological concepts. So the whole thing is that we are trying now to create pipelines. We are documenting our data sources by such a pipeline consisting of small filters describing the different parts, accessibility, where to download, get the data. Parse is how to interpret the data and populate such a data model. So get the data in the form it exists into a formalized one. And the mapping is really give it a semantics, map it to the ontological concept. When you want to go on the other side and really represent the data in the form, so in this case, the user want not only a nice TEM image as we see to the left, but also some pre-processing of it. He has a new data model that represent how he wants the data. That is, of course, mapped to ontological concept, and then the system itself, and then he has a generator. But the system says populates this data model, and then he can serialize it the way he wants to. What I really wanted here was to have a little more hands-on demo. It's not so easy to go into web pages with this setting here, so I just show a screen dump. But this page here on GitHub is actually it's in a branch right now. It will be soon merged into master, but it's something where you can go in and look at. Yeah, the demo is implemented in the script called demo.py. We are using a set of technologies that you see down to the right. So we have Tripper that is used to represent the knowledge base. We have Delight that is used with data models, and then we have OTAPI that is the technology that we set up this pipeline documenting the data. So first, we want to have a triple store. We use Tripper, so we have a triple store. First, we instantiate that, and we use, in this case, a very simple in-memory backend RDF click that, but we can connect to any of the shared triple stores that we might have in the projects. Then we are simply, the next line populates the triple store. There's a small utility function that does that. So that will simply put all our data documentation in that triple store. So now from now on, we are working against the triple store. Then we define some handy namespaces. For one is the PM namespace, that's what we're using for our data models, and then the OTA interface ontology for that we are relating to how things are structured. Okay, the use case. We want to be working on aluminum alloys. And the aim here is really to develop new alloys with improved properties. To do that, we need to understand how these alloys behave. So we know the alloy composition, we can have many samples, and we can influence these alloys, improve them by thermomechanical treatment, and of course their composition. That is what we can play with. And the idea here is to test around and study. So in this case, it's very simple. We are having the same alloy, heat treating it two different ways. We have the condition A. You start solution heat treatment, crunch it to room temperature, immediately heat it up to 185 degrees for 5 hours. When you're heating up, you give some energy to the system, create a lot of mobility and homogeneous solution, small precipitates forms. You can see that these are small needles that are forming, pointing in crystallographic directions. These needles are really important. They give the alloy the properties you want. And we want to control the distribution of how many, the size and so on. Okay, we have another condition, condition B. We have done a slightly different heat treatment. Here we crunch down to room temperature, keep it at room temperature for a month before we do the final heat treatment. But in the just after 5 minutes, we heat it up to 90 degrees. So that gives us some additional effects. So it just shows that we have a lot of possibilities to play around. So the question we might ask is really, first, how to document the data. We'll show how to populate the triple store. Then a very simple example of looking what data sets we have then in the triple store. Until we get to the real questions. How to view the Okay, so how you can view the data in different ways. So let's look at the documentation of the data set. It's a little distant for me now, but the documentation is done. Right, what you see here is a YAML representation of the data. Of course, that is serialized into RDF in the triple store. And so what we can see here is here is a unique ERI that represents one TEM image we want to represent the triple store as an individual. And then we have some additional data where you can download. And then the parser we are going to use, so that is more, now we are going, is a special, more dedicated configuration in the parser. We have a next step would be mapping, so relate this image to the ontological concept. We do that by, so these are the properties in the image you see here, and they are then mapped to, okay, the file name in our data model, we map to the concept file name in our OTA interface ontology. The data is, in this case, just a simple IMO array and so on. The pixel unit is a unit. It could even have been a length unit, and so on. The pixel site is a IMO length. This is the way we are documenting the data sources. So we have these data models. They would be nice also to represent in the ontology. That's right now they live outside, but what we live inside the knowledge base is this YAML representation that you see to the left that document, in this case, is a single TM image. And the document so it's rather minimalistic, but still semantic enough that we really can use it. So the first step, this first question, explore the data. This is very simple, just some few lines of Python code using Tripper. What I'm doing here is simply to ask for all data sources we have, and then afterwards all data sinks, and it just lists the two nicely down the screen. We can of course do the same with Sparkle, but this is an even simpler. Tripper has both interfaces. What Fadja was showing here was a very nice. We get a much better. Fadja showed us a much more graphical and more throughout way of exploring. But here, what I'm showing here is a simple Python interface that gives us a basic possibility. So going back to the real question he had, we want now to access the different data sources. You see on the left, the data source we have there, 3 CEM images. These raw images here in a very proprietary file format. DM3 stands for Digital Micrographs version 3 format. We have a data model for them, and we have another data set that with a CSV file with the alloy composition. We also have a data model for them. We want to get this data now in different ways. The images you could, for instance, just get a viewable thumbnail from in a file format that most readers support. So that would be a PNG file. We have a data model for that. 2 different data models. We use this concept of mapping. So I'll show you next slide. Then we have this. Maybe we want, because these digital micrograph files, they contain not only the raw image data, a lot of microscope settings and so on. You also want to view that and again the JSON dump of it. There's another. We can do that. We have a generate partial pipeline to document that. And then finally, we have documented how to get precipitate statistics. But that is a little more complex process, because if you're looking to get the statistics, you have to count the number of precipitates, measure the length, measure the cross section, do a lot of image analysis and so on. But assuming we had such a nice image analysis software that can take as input a data model showing for the image, output a data model for precipitation statistics, we simply combine them. And the final part here is we want even to combine this precipitation statistics with the composition in order to create an input file to a precipitate model that we further can try to investigate things. Next slide. So here we have the mappings for the, you can see up to the right, but we have the TM image, we want to PNG. What happens when you do this very short, simple line of Python code? Get data is a function. It takes 2 arguments. argument, the first argument is a reference to our triple store. The next argument is simply the steps. And again, what you have is a tuple of containing the ERI corresponding to the image, followed by the ERI for how we are documented the way to view it as a PNG. So simple, you're just referring, you say, I take that image, I wanted to view it that way. We could have taken another image and had the same PNG. So these also shows the very flexible nature of the OT API. We can mix and match. And simple under the hood, what this get data function does is to create an OT API pipeline and actually run it, call the get method and it. And in this case, we even transfer between two different data models via mappings. But that is nothing you see as a user. It's all hidden. Next slide. The same thing here. We are going from image to, in this case, JSON file. Here we have this generate method now operates on the same data model as the image. So in this case, we don't even need the mapping. So it's just a generate that we connect. Next slide. Then we have this case here with precipitate statistics. Up to the right, you can see we have the image. We have this software analyzer, and the output is how we want to show it. The visual. What is under the hood is generated is a connection 3 partial pipelines. One reading the image, one for the analyzer, which is simply convert between two data models. So we ontologically describe inside the model in the configuration what is input, what is output. It's generate, and finally is simply a partial. What do we want to do with this precipitate statistic? Yes, we want to view it as a CSV. When you execute it, you get the CSV. And the final is the next step. Next slide. We take it one step further, where after we have created this CSV, or rather not created the CSV, but get our data model for the precipitate statistics. We want to combine it with the alloy composition in order to create representation for the input file for a precipitation model. You can see partial, in the here connected 4 partial pipelines. Again, the arguments to this get data functions are simple. Just the triple store and then the steps, these 4 steps we have. The 2 data sources, how we want explicitly how we want to do this analyzer we're referring to, and then the final thing is how we want to get it. So in this case, we want to create an input file to a precipitation model. The order is not that important. The only thing is that, of course, you need to put the sources. They need to be provided before they are used. Okay, then I'm starting to get to the final summary. So what I'm trying to show for you is that we now have a very simple Python interface helping us connecting, being a data consumer, helping us to connect to different data sources and get the data in the form we want. We do that by documenting the sources, documenting different ways we want to consume the data, and then simply say, connect them. I want that and want that. We have the very flexible language. And we have showed it here on this case for aluminum alloy development.